in the future world we're all designing for, I do think that centralized manufacturing is going to be very, very difficult to defend, just like a centralized aircraft carrier is. And so anytime you can take one asset and break it into 100 assets that accomplish the same thing, you add a ton of survivability. Everyone's losing their minds about China's like 6th-gen fighter jet. I don't worry about it that much because I think that with Glide, if I actually had to go to kinetic conflict with China, I would be able to take that thing off on the runway. It's becoming almost exclusively an unmanned war. In World War II, we had very, very clear superiority of manufacturing. I'd love to see a day where we have that again. I'm pushing for that day. I know most of us in industry are pushing for that day. We need to be very, very, very precise about looking 10 years in the future, identifying where we need the offsets, and then investing deeply in creating that capability.
Ethan, thanks for joining me.
Yeah, excited to be here.
Let's just start with your journey. So if the audience does not know, growing up and helping your grandpa on his farm in Texas, what was that like?
Yeah, I mean, obviously an awesome way to grow up. Grew up in Bernie near San Antonio, and yeah, spent a lot of time making things. My grandpa farms, my mom grew up on the farm, went back there about a month every summer, helped him run the farm, and then, yeah, kind of got into stuff through there.
What inspired you to start Mach Industries?
Yeah, I think it's two effects. So one is a ton is changing in defense, right? So autonomous systems, a post-unmanned world is going to have to make us completely reinvent the way we fight wars, and then two is global power competition, right? So the threat of China. And I think the convergence of those two things makes this industry existentially important to work on for the next few decades. And it's obviously, as an engineer, it's also a fascinating place to be doing work right now. It's some of the coolest engineering happening on Earth. And so, yeah, in high school, got really passionate about what it actually looks like when we have unmanned systems sort of in the limit, right? Because it's very easy to extrapolate sort of one layer and imagine a world where you have like mortars strapped to quadcopters. But if you take that 10 iterations deep and look at the way wars will be fought in 10, 20 years, it's pretty unrecognizable to what we have today. And the systems we have today likely won't survive first contact in those wars. And by systems, I mean aircraft carriers, I mean strategic aircraft, I also mean manufacturing, and I mean supply chains. And so we as the US and our allies are going to have to completely reinvent the way we fight wars. And again, it's pretty existentially important that we do that very well. And so in high school, just became very passionate about that, started reading about the space, wanted to get involved through, actually the military was the initial path. And so I went to school on ROTC scholarship, quickly got concerned about sort of the pace of the way the industry is moving, and so decided to start Mach. Back then, there was like a 1 in 100 million chance that Mach actually worked, and I'd say it's still low probability, but like we've continued to march through stuff that I'm really excited about potentially having a change on.
So I believe even before going to college, you were already prototyping defense applications using your own savings. What did you learn from those early experiments?
Not that much, candidly. Like, so yeah, I had that business doing like metalworking, furniture making stuff. Like my grandpa's farm, I'd go and just collect steel and like forge knives and stuff, and then use that to fund some of these bets. And so early work, there were things that I could think a lot about, and like design and patent, and then there were things I could actually build, and unfortunately those things didn't overlap a ton. So back then I was really obsessed with fixed-wing UAVs. I was really obsessed with some of the stratospheric work. Really the only thing I could prototype at the time was more of the hydrogen side. And my reason for thinking there, and we'll talk about sort of how that's evolved over time, but initially like it's very clear that our energy supply chain and then like logistics lines will not survive first contact in these wars that'll happen in 2 to 3 decades. And so I'm a big proponent of having a field sourceable combustion energy. Hydrogen's like the easiest there for many technical reasons. I don't think it actually makes sense for a ton of applications, but in high school I was really, really passionate about that, right? Essentially finding a way that we could field source from any energy source, the ability to fly performance systems. And so that was the form of guns, that was the form of some like combustion propulsion techniques. More in high school is the guns. And yeah, I built like I've talked about this, but my parents wrote me like a couple $100 check. I built like it was a backpack bazooka thing. My girlfriend at the time helped me build it, and it was just like gear feeder batteries, electrolyzing water, and then combusting and shooting like ball bearings. Again, I mean, I didn't have money to do many cool things, but I could think about cool things.
So I think most of the world is still of the opinion that you need to go to school, get a degree from a good college, work for someone else, climb the career ladder, and then all that stuff before you can even think of doing something of your own. Obviously, I think that's changing a little bit now, but I'm curious how you crossed the necessary learning curve for starting a defense company so fast.
Yeah, it's a great question. And I've definitely been super fortunate, right? Like I've obviously worked hard, but I've also been incredibly lucky to meet people who have given me this opportunity and who have helped me build these things. And so I think for me, the optimization was never actually success. It was certainly never money. But I think the mean of doing Mach was probably certainly failure. That said, I was pretty squarely optimizing for like the 1 in 1,000 chance that like Mach actually had like the impact I wanted it to have. And hopefully like it's actually looking more and more likely by the day that we'll be able to do that, which is exciting. So it helps if you have an optimization where you're not at all afraid to fail, right? Like Mach could have, when I was like living in the shop a couple months after dropping out, like Mach could have failed then, and frankly I would have been glad I made the decision. Right, like on a mission like this, you'd rather go out swinging. And so you can't fear failure. Second, I think it's incredibly helpful to like surround yourself with intelligent people and with mentors. Like I was super fortunate in the early days through investors, through other people at MIT, through military folks to meet people who like showed me the ropes and showed me how to do this thing. Like you cannot do these things on your own. And it is way harder to learn on your own through failure than it is to learn from other people's failures or just other people's experience. I mean, on the actual education side, I'd say it's actually probably the easiest. Like we're at a day and age where like the stuff I would have been studying at MIT is basically free through MIT OpenCourseWare anyway, right? And so in school, you're actually more optimizing for learning to work on a team, for learning to interface with building connections, and that's what you're missing out. It's with AI and then with MIT OpenCourseWare and then just across the board, it's actually regardless of how technical you are, you can be doing the most technical thing. You can be like an RF radar engineer, right? But it's actually probably preferable to drop out. It's like a controversial take I have and just like attack the specific problem. You won't have the breadth, right? But like it's very easy these days to direct your energy around a specific problem. Use YouTube, use all the tools to learn that thing. It's a lot harder to figure out how to work on a team, how to like effectively work with people, and that's where I think having mentors and then also being high growth, like being willing to fail, not fearing failure, and then learning from failure correctly is super important.
Yeah, and I think dropping out from an Ivy League college or like MIT and stuff, like it's slowly becoming like the new credential, I guess.
I wouldn't say credential. Like, look, I wish I could have finished MIT. Like, there's a lot that I didn't learn, and it probably would it would be net better for me if I had. But like, I had stuff I had to get done, and so I fear a world where it's considered like necessarily credential to drop out of those schools because there are super important things those schools teach. It's just it looks completely different for different people depending on what you're optimizing for.
Yeah. So for those who don't know, you raised about $85 million across both your seed and Series A rounds. Why did you decide to raise that much money, and what do you think most convinced investors about your vision for Mach?
Yeah, on my end, it's pretty clear why Mach has to be a capital-intensive business, right? So we're currently bringing 3 products that are complex, aero, mechanical, like obviously manufacturing software products to market in a very regulatorily intensive market, right? And so for us as a company, like for me, it was very clear why we needed to raise that capital, right? For us to be able to build out an ecosystem of war-winning products in the next 5 years, we need capital to deploy around these things. For an investor, I mean, when we raised the capital, there was execution that had happened. So I think there's this misconception that we hadn't been doing flight tests or hadn't been doing other things. There were actually several programs up in the air at the time. We had hired that Lincoln Labs team that we ended up spinning off, but had the working reactor. We had pretty active customer communication and like had a pretty clear plan for what we wanted to do as a company. And so on our end execution, I think we're in a pretty good spot. And
I believe you guys had like 6 different products starting out. Right?
We did, which was an interesting approach. Not necessarily one I'd recommend wholly, but it worked for us. So for me, as like an 18-year-old going out to raise capital for Mach 19, however old I was, I could not claim to understand like the nuances of DoD, right? And so there are a lot of products that either on the technical side or more often on sort of the commercial side, you really can't assess if they're going to be winners or not until you bring them to market. And so for us, our products have to be winners. Like if I go and spend $15 million developing a product and it flops, the company's over. That said, like getting to a prototype, a flying prototype that you can get in front of customers is actually incredibly cheap, right? It's usually on the order of sort of like hundreds of thousands of dollars and a couple of weeks of engineering time. And so yeah, we got to notional prototype across like 6 different programs. That was kind of with the seed funds from Sequoia. Took them to customers. A few were very clear sort of winners. A few were very clearly not winners. We invested in the ones that were winners, cut the ones that weren't, and then went into the Series A with a much honed product line, much more honed in product line. They were very confident would be winners, and so far they have been. So yeah, it's an approach that is certainly painful, right? You have to be willing to cut programs and you have to be willing to manage complexity, but it's also the best way to buy down risk as a business, at least in our case. That might be unique to DoD, but that's the approach I took.
I read a blog post from you where you said Mach aims to be the designer and manufacturer of full vertically integrated supply chains. What's the rationale behind that instead of just outsourcing various manufacturing processes?
It's security, performance, and then a bit of like control. So on the security side, if we go to war and if I have to scale production, the more of my supply chain I own, the more obviously secure my ability to ship the products are. Like that's pretty intuitive. On the performance side, if you look at an asset, we're looking at Glide now. If I can design every atom of Glide to be optimized for the mission set, and moreover to work with every other atom of Glide, Glide can be like atomically optimized to do a specific mission, as opposed to kind of bending that mission around existing hardware. So the more of Glide that I can own and like specifically designed to do a mission set, the better Glide is going to perform. And then on the control side, it's really nice just to not have to add variables. Like you never know when a supplier's going to turn around and screw you over. It just minimizes variables and you control your own destiny. And it's actually way harder on the execution side, but there are also fewer external risks.
I think we'll get a tour of the factory later, but you're also like an advocate of decentralized factories.
Yeah.
Which might be a little counterintuitive because we just talked about like not outsourcing stuff, but why do you?
Yeah, absolutely. You can have decentralized vertical supply chains as one. Like those aren't necessarily correlated. I would say you're optimizing for different things. So if you're building a large centralized factory, you're optimizing for very specific things, and those optimizations are important. And like we do need some of those. But at the same time, like in the future world we're all designing for, I do think that centralized manufacturing is going to be very, very difficult to defend, just like a centralized aircraft carrier is. And so anytime you can take one asset and break it into 100 assets that accomplish the same thing, you add a ton of survivability. And so for us, and it really starts on the design side more than anything else, but if our assets can be designed to be manufactured in much smaller factories, again, we're optimizing against certain things, right? Like it's actually probably slightly more expensive to do these things and certainly harder to do these things, but you end up with a supply chain that actually continues operating in the war you're designing your products to fight.
Mm-hmm. I think I heard you say that, maybe it was in the New Founding podcast, that the stratosphere is the most important domain of the next century. Why do you think that?
It's a great question. So when I say that, I'm specifically talking like high altitude balloon systems. And this is an area we're investing very heavily in as a company. It comes down to the ability to sort of override the tyranny of distance, and then just massive cost asymmetry. Right, so in the Pacific theater, a huge deal is range. Less so in Europe, but still super important in Europe. And that's just kind of the way warfare has been forever, is range is a very, very important metric for your weapons. And if you can put something up in the jet stream and have it go hundreds to thousands of miles, it's an incredible capability that you can provide very cheaply. And then similarly, the ability to hang sensors, hang comms, hang other things at altitude, where they're significantly more expensive to take out than they are to put up, you can create massive cost asymmetry. So something we talk a lot about as a company is providing an offset, right? So like in World War II, we had very, very clear superiority of manufacturing. I'd love to see a day where we have that again. I'm pushing for that day. I know most of us in industry are pushing for that day, but it's unrealistic for us to think that that's going to happen anytime soon. Mm-hmm. So in the near term, if we're manufacturing the same thing China is, we're going to have a less capable fighting force, right? Like they generally match us on tech, specifically on unmanned systems. That's a bit of an exaggeration. Like there are areas where we do have clear leads, but like holistically, we don't have a massive advantage on any key technology, and they do dominate on scale, which means that we need to be finding ways, unfortunately, to fight asymmetrically, at least until we can once again match them or ideally exceed them on manufacturing capacity. And so stuff like the stratosphere are very sort of quick wins to provide massive asymmetry in the face of an overwhelmingly sort of dominant manufacturing scale.
Mm-hmm. So we touched on this towards the beginning of the conversation, but I believe your vision for Mach starting out was a hydrogen-first approach to defense. How's your view changed on that?
Yeah, so I wouldn't say that was my vision for Mach, right? Like my vision for Mach is to provide the best possible capabilities to prepare us as a country. I think a large part of that certainly was early on hydrogen, and it was specifically so that we could have field sourceable sort of, combustion energy techniques. I still believe in hydrogen for a number of things. Like I think that if you need to propel projectiles very quickly, it's a really cool capability. I believe in combustion-like gas guns more than I do rail guns. And then for stratospheric systems, it's going to play a crucial role. So two things have happened. One, I've become less bullish on Mach working on combustion-sourced fuel in the near term. Like that was just a bit of a naive view I think I had in terms of being able to push a new fuel to the DoD. It needs to happen. It's going to happen on some timeline. But I think in the near term, the much lower hanging fruit in terms of the ability to deliver important things to our warfighter is in the form of unmanned systems. So it's the importance sort of stack rank has changed for me. And then on the hydrogen side, I think hydrogen was just kind of a bad technical bet on my end. Again, I still believe in it for certain things. I think if you are betting on a field source combustion fuel of some sort, I think methane is a way better bet. Methane requires hydrogen production, but it's just a way friendlier form of storage. And not friendlier from a safety standpoint, more so, well it is, but more so from like an energy density standpoint. Like energy density by volume is way easier, and then it doesn't try to escape all the time, which is helpful. That's not probably work we'll do in the near term as Mach, again, right? Like our job is to provide capability. You have the actual assets providing the capability. You then have their logistics, you have their manufacturer, you have everything that goes into fighting a war. Right now we're very focused on the assets and the manufacturer. We'll probably work on the energy at some point, but it's not the immediate place to add value.
Do you want to give a brief overview of the two products you're working on, mostly focused on nowadays, like Viper and Glide?
Yeah, absolutely. So Viper is a jet-powered vertical takeoff strike aircraft. So it's essentially something, if you or I as operators, we could deploy, set on the ground with no infrastructure, takes off vertically, transitions into horizontal flight, and then delivers a warhead far downrange. And so it's very optimized for a few things. One is obviously low cost. Two is operation in a GNSS denied and just generally an RF blackout environment. And so lots of optimization there. Three is sort of no infrastructure for two reasons. One of the platforms we're sort of looking to provide a similar capabilities to is called HIMARS. And so it's rocket-based artillery system. You essentially, in the US, it's $5 million. I think export is a $20 million truck that launches several $100,000 missiles. The issue with having a truck like that in a future war is that becomes a very centralized target. And so once the adversary has similar capabilities of ISR and strike, that's going to be obviously targeted. And so everything you can do to take similar capability and then decentralize it, break it up into more units, you add massive survivability to your platform. And so our goal is to give similar capability to ground maneuver units such that they can actually conduct their own precision long-range fires. And so ideally, you and I as two operators can throw up ISR and deep strike. And there's less of an ability to target some centralized asset. That's the first reason VTOL makes a ton of sense here, is because then you and I can throw it in the back of a truck, we can set it on the ground really anywhere. The second is once you start deploying a large number of assets. So a lot of these jet-powered assets have flight time in the tens of minutes or low hours, right? And so it's very, very meaningful if you're trying to have 200, 300 assets in the air, how quickly you can launch them. And so if you're imagining a world where I'm going to try and put up 500 Vipers and have them all talk to each other and communicate and do interesting things downrange, it's very, very harmful to only have 5 catapults, right? Or only have 1 runway and be able to take 1 off at a time. And so if I can take these assets and stack a bunch of them in a parking lot, I can put a lot more in the air at a time. And so by being VTOL, you become more survivable. You can also put more assets downrange, which is super, super meaningful. Glide, I can tell less about, even though like I can show it, but it's not jet powered. It's a glide vehicle, hence the name. And that'll be a high altitude GNSS denied, sort of very difficult to detect strike asset.
Are there any timelines on like launching both the products and having them
yeah,
produced at scale?
They'll be launched in the next few months, and we'll have some manufacturing announcements in line with that.
Nice.
Yeah.
How do you ensure that product development isn't siloed and build a feedback loop between architects, designers, and the manufacturing team?
Awesome question. Yeah, I love that question. I'm a big believer as much as possible in like a matrix style engineering org. This is going to get really boring and I apologize. But there are kind of 2 major ways to do development of a program or just management generally. One is where you have like verticals to do a specific thing. And that would be if we had separate team for Glide, separate team for Viper, separate team for our other products. Same with like having business units essentially. And so Glide would have its own aerodynamicists, it'd have its own electrical engineers, it'd have its own like RF people, own mechanical engineers. Anyway, all like 20 different domains that go into like producing a product, you recreate per vertical. And there are big advantages to doing that. The biggest advantage is that your engineers can be laser focused on just shipping the product. So you do this when you're very, very focused on building a product as a company, which is valuable, and like there's total merit to this. The other form is a matrix form, and any engineer knows this, and frankly, most people who manage teams, so I apologize for like over-explaining things, but the other way is matrixed, where I will set up an electrical team, and then I'll also have a mechanical team, and then I'll also have an aero flight sciences team, same with GNC, and then those resources are shared across your various programs. And so the advantage of doing that is that all those teams then share knowledge as much as possible. So like we're building a lot of software tooling to do product development. So we have a software suite to do aero, we have a software suite to like simulate an entire vehicle, similar on the avionics side, right? So like we're building an avionics stack, we're building components, we want those components to be shared. And so the advantage of being matrix is that all of that knowledge can be shared across your various programs. Is first off, the next thing is that it's way easier to spin up and spin down programs. So let's say tomorrow I walk in and I want to do like a counter UAS missile, let's say, right? Like if I walk in and want to do that, then I can quickly pull a team together of engineers in the matrix structure and spin that program up same day. And then similar, like if for some unforeseen reason I have to shut down one of my programs, I don't have to lay people off. They can then retask to other programs very, very efficiently. There are huge downsides to this model, right? Like you want to avoid a world where your engineers become consultants. If you're an engineer and I'm asking you to build 50 different vehicles at the same time, each of those vehicles will get 2% of your time and they'll all suck. And so it's a balancing act between the two. But for us, like my main optimization with our engineering team is reducing cycle time, right? So like Viper for us on our last design, on our last rev, we went whiteboard in like September to flight, successful VTOL in like mid-January, right? So however many weeks that is currently kind of what the loop is. I want to get that down to a couple days, such that we can identify a warfighter need, spin up a team. This is where Matrix is insanely helpful. They have existing tools, they have existing subcomponents, and then deliver that in a couple of days.
I think Elon's pointed out that the harder part is manufacturing things at scale and not necessarily designing. Not to say that designing a prototype is easy, but just manufacturing stuff at scale is often underappreciated. What are your thoughts on that?
I generally agree with him. I think it would be, I've not manufactured one trillionth of what Elon has, and so I can't say I have any insight here, but in my experience, that holds true. I think it depends on the type of manufacturing you're doing. Like if you're designing a water bottle, almost like the entire optimization is manufacture. I think on complex aerospace engineering systems, like engineering does become more than 10%, I would argue. I also think that like if you're doing your job right, there's a very blurry line between engineering and manufacturing, right? Like your engineers, manufacturing is just engineering at the end of the day. Everything's kind of engineering. Scale is really hard. Getting your quality systems in place is hard. Getting your ERP in place is super hard. I'd say for us it's like 80-20, but that's splitting hairs.
Yeah, I guess there's a lot of regulation and bureaucracy in this sector, and Elon also has this famous rule that at SpaceX and probably at his other companies too, where he asks everyone to question every requirement.
Yeah.
And he'll often like track down the exact specific person behind a specific legal requirement and then contact them directly. So I'm curious if you've faced many regulatory hurdles and how do you and your team navigate them?
It's a great question. Yeah, I mean, we're building munitions in California as a startup. So we're like one of the more regulatorily intensive companies, and then trying to sell them to DoD and overseas allies. So yeah, super complex business from that perspective. It has not been the hardest part for us. I mean, I was super fortunate to continue to get to work with like what I'd consider one of the best lawyers on earth. We just have an incredible legal team here that I think has made stuff flow smoothly. And then we also have people on the team who've dealt with these things before, which is lucky. Like Elon, when building Starbase, no one had really done a program like that before. We will have programs that no one has ever done before. I'm fortunate to get to work with people who have not developed similar platforms. Like I think our platforms are sort of incredibly capable compared to really anyone else's on Earth. But like in terms of form and factor as a business and a lot of the regulatory challenges, there's prior art there, which is helpful. It's very, very important in these cases to identify what the challenges will be really, really far out. Any operations in business, you're balancing like fire and ice. And I think fire in the regulatory world is very dangerous. You want to move towards ice and think 2 or 3 years out about what regulatory challenges you'll be experiencing and have a very clear plan in place. It leads to some interesting conversations with my lawyers when I'm talking about like what the regulations will be on like building modular nuclear reactors or things that are like not at all tied to the business currently. But I think the further you can look out is super helpful. I think being flexible in your operating models is super helpful. Like having the operational flexibility to do things in different places is really helpful. Frankly, doing small things, as dumb as it sounds, is really, really helpful. Like flying Vipers and glides is significantly easier than doing a lot of more regulatorily intensive things purely through scale. We can ship them to more friendly places easier, like stuff like that. And then just having excellent talent. Like our manufacturer has built auto factories that roll a car out every like 45 seconds. So he's in California. He's very familiar with what this looks like. My GC did compliance at Palantir for a decade. They're really complex. And so I've also just been lucky to work with really good people.
Yeah. How do you balance like the build fast and break things spirit with the safety protocols required for the kind of stuff you're doing here?
There really can't be a balance. Like I think that was the big mistake, is perceiving that there was a balance. You can't do dangerous things. You can do everything you can to make things that would normally be dangerous non-dangerous, but if there's a world in which someone's like physically in danger, you don't do the thing. And even if that means shutting down the company, you don't do the thing. And so for us, it's mostly have the capital to do things right, have the like EHS people in place, have the safety protocols in place. And it's tough because like I love having a very young, high energy culture, right? Like I'm young, most of our engineers are relatively young. We're injected across the board with people who are like total domain experts and do these things very well. But I would say there's no balance there, at least on the safety side. Now, if you want to talk about other things like risk on whether or not we should develop a product, or risk on like if it makes sense to invest in CapEx, that is where I'm very, very risk tolerant. I think if you're not swinging for the fences as business on building weird products, like Glide at the time was a very, very strange program to be developing. Like most people told us it was stupid. We decided to build it, and now there's like very strong customer traction. So yeah, there are areas of the company where you should be investing in risk, and there are areas in the company where it is not a balance.
There was also a mention of the time until China invades Taiwan, and at first, like when I read that, I thought like this wasn't a joke, right? This is like a serious matter, and like there's probably like some good reason to have it there.
Yeah, I mean the CCP has published their timeline to military readiness to invade Taiwan, and so it's not my place to comment on whether or not that actually happens. I don't think anyone really, other than a few people within the CCP, know if that's going to happen. But the reason I dropped out of school, the reason we're doing what we're doing is to be able to provide deterrence against that case. And so, yeah, I mean, that's one I totally stand by and have considered bringing back. It's absolutely not a joke. Like, it's in no way a joke. It's incredibly serious that we're playing in a very important role in arming allies against potential sort of invasions on their sovereignty. And if I can ship 10,000 Vipers to Taiwan before that day that China's claimed, like their calculus is going to look pretty different on being able to do that. And that's the same optimization for anyone working in the space. I don't care what defense company you're at, not even necessarily defense tech. Like we across the US and partner allies, like we're optimizing knowing that we're in a global power competition and that there is evil, right? And that evil has published a date for readiness. So we better be ready for that date. So yeah, I'm pretty hardcore about that one. I can understand why it would ruffle feathers, and like if that's the case, people shouldn't work at Mach in that case. Like if you're working at Mach, you're working to provide security for ourselves and more importantly, arguably for future generations and for allied countries.
So let's talk a bit about the future of warfare. What do you think total victory in major wars depends on a few years from now?
I can't necessarily speak to total victory. I can talk to sort of the tech that will enable them, or hopefully deter them. I would say in the next 5 years, the trends I expect, one is just total mass proliferation of precision long-range fires. So essentially the ability, if you want to hit a target several thousand miles away, to do so much cheaper and a much harder to counter way. Viper sort of is one of those assets. Glide is one of those assets. I don't know if you've seen, but China just ordered 1 million long-range strike drones, right? So these things will be produced, are already being produced in the millions. They'll be incredibly hard to intercept, especially at cost. That's kind of the first order effect. Based on that, a few things happen. One, again, securing centralized assets is going to be incredibly challenging. And so if you're a shipping vessel trying to cross the Pacific, in the case of a direct kinetic conflict between the US and China, or really China and anyone, is going to be incredibly challenging, right? So we'll see stratospheric assets doing sensing, we'll see space-based assets doing sensing, we'll see airborne strikes, we'll see unmanned surface vessels, underwater autonomous vehicles, right? So like we're already seeing some really terrifying stuff happen in Ukraine with heavily armored assets. So something I can't do when looking at Glide is add armor because I have massive weight constraints. If I'm an unmanned surface vessel, I can add a lot of armor, where even if I'm hitting you with a 30 millimeter gun, there's a world where that asset's still getting through. And so that's really concerning. The far more concerning stuff is the underwater. So underwater's the only main domain that I believe will remain very difficult to sense in. So all of this is enabled by sensing, all this long-range precision fires, right? So there's the longest time where if you're in the Army, you could shoot further than you can sense. For the first time in a while, we can sense way further than we can shoot. And the sensing numbers with stuff like the stratosphere or with some of these like multi-day loiter $100,000 aircraft is going to continue to proliferate. But then, yeah, once you can do that, then you can actually shoot. And so another scary thing here is that doesn't hold true underwater. Like it's still incredibly hard to sense underwater. And so you can still obfuscate, you can still remain stealth with relatively large assets. The unfortunate fact of the matter there is that with unmanned systems, we're going to see millions of underwater vehicles doing strikes on boats. And so boats just one example of a centralized asset, right? So you've got unmanned surface vessels, you've got underwater vehicles, you've got things like like Glide, striking boats hundreds to thousands of miles away. Really concerning. I think the ability to get centralized air power off the runway is going to be incredibly hard. This is a controversial take, and I understand that. And I'm very glad we have these things in the arsenal, and we should keep them in the arsenal in the near term. But if you look at $100 million aircraft taking off from a runway anywhere near Indo-PACOM, or not, in some worlds even runways not near Indo-PACOM, you have a very clear idea of where that aircraft is, and targeting it on the runway, literally as it's trying to take off, is going to be relatively straightforward with some of these assets. And so once these things get in the air, generally actually relatively survivable, especially at range. You have low observability, you're moving quickly, you're high altitudes, you're difficult to sense. But if you know where the runways are, and if you have unjammable GNSS denied assets, very, very in the future straightforward to strike those things. And so that's why we're building VTOL stuff, right? That's why we're building $100,000, $200,000 VTOL aircraft is to counter that. But I worry a lot about that. Fortunately, any of the trends I'm talking about are also trends we can leverage to create an offset, right? So when I talk offset, China makes 237 times the shipping tonnage of the United States. That's a huge vulnerability we have. But if with something like Glide, I can offset that, that's a huge advantage. And that's why it's really, really important that we be investing in unmanned systems. And instead of saying unmanned systems is this thing that we're like, for some reason, because of DJI, because of battlefield use in Ukraine, I don't know why this is the common perception. And unfortunately right now it's true, but it doesn't have to be, that we're behind on unmanned systems. If we invest very deeply and get these things right, it's an area where we can build massive offsets to China. And so if we're worried about China building massive fleets of aircraft, be able to take those aircraft off before they get off the runway. Everyone's losing their minds about China's like 6th-gen fighter jet. I don't actually think it's 6th-gen, but it is a fighter jet with no vertical stabilizers. I don't worry about it that much because I think that with Glide, if I actually had to go to kinetic conflict with China, I would be able to take that thing out on the runway. And so we need to be very, very, very precise about looking 10 years in the future, identifying where we need the offsets, and then investing deeply in creating that capability. That's kind of the first order stuff. I could like extrapolate that and talk about future stuff. I'm happy to if you want me to. I can
just
rant
curious
about it for way too long.
Underwater vehicles. Are there any Mach products in ideation for underwater vessels?
There are always Mach products in ideation for any number of things. The question is usually the seriousness. No, not currently. It's a domain that's interesting to me. The reason I actually likely won't, I might eat my words here, and I can't say I won't. You should see our pitch decks. I change product roadmap often. It's actually something I'm relatively proud of. We need to have flexibility, and we need to have an engineering team capable of delivering whatever the warfighter needs. I personally, right now, my thinking is that we likely won't, because I think it's far easier to accomplish most of those things with airborne assets. So if you're trying to do underwater sensing, underwater vehicles make a ton of sense. And if you're trying to launch airborne assets, underwater vehicles make a ton of sense. Those are actually relatively saturated right now because of that. And they're excellent companies working on those applications. The area I don't see as much work being done is the one I described to you, which is actually taking out other vessels. But I think it's easier to do that with the air. And I'm also building a product line for the world that exists someday where you actually don't have centralized naval vessels. Like my optimization with products is what works today and then what works in 10 years. And let's make sure that we're sort of fulfilling both of those criteria. And if I'm building underwater autonomous torpedoes, essentially, they work great today. But if I truly believe that the future is one where we don't have commercial, or where we hopefully have commercial ships, where we don't have centralized ships, then that doesn't make sense to build. I very much hope I'm wrong about that world. I very much hope we continue to, but like Mach's job is to be kind of the insurance policy for a post-unmanned world. Like if these bets unfortunately do play out, if the stratosphere is as important as I think it's going to be, if unmanned or if centralized targets are as difficult to defend as I think they will be, then Mach's job is just make sure we have what are right now kind of strange assets like Glide that don't make a ton of sense, but have them in place for that world.
I feel like there's some resistance to the idea of a future where wars are mostly just unmanned systems, and there's a lot less human input towards that. Why do you think that is?
One, it is scary, right? Like, and rightfully so. And the idea of having like AI controlled autonomous systems is nerve-wracking for people. Now, I would argue that sending something forward with a computer vision model that's right 99.9% of the time is orders of magnitude better than what we do right now, which is send forward either a dumb artillery shell or something with a GPS jammer that's going to be jammed and go haywire and miss by a quarter mile, right? I would argue that you're moving in the safe direction, but obviously the moral implications of doing that are huge and something that should be weighed incredibly heavily, and fortunately not something I make the decision on, right? So that's something our lawmakers make the decision on. We'll be ready to support whatever the U.S. decides it needs to do to win wars. That's one. I think the next, and one that I do feel a lot more strongly on, is humans are always opposed to new ideas. Like anything new is automatically scary, especially when you've been in industry for decades and when your job is tied to a certain way of thinking. And then there are other borderline corrupt reasons. Like I would argue the fact that a lot of our military industrial base is a jobs program is existentially dangerous to our existence as a country over the next few centuries. And so, yeah, it's scary. It's scary from a reason that makes total sense, which is the AI reason. And it's also scary because it's a new thing, and it will have to change the way things are done. And anytime you change the way things are done, people's jobs have to change. And there are industries where it's okay to think that way, and then there are industries where it's not. And when you have a peer power, potentially we're the ones actually now trying to maintain near peer, that is investing heavily in these things, it's not an option. You have to do it. And then the final option is we have used aircraft carriers to project power relatively successfully for the last almost a century, right? And so the idea of saying, hey, a world's coming where you can't defend your centralized aircraft carriers, or where you can't defend your B-2s sitting on the runway is objectively terrifying, because in some people's minds, you're seeing that as saying, hey, there's a world where you can't force project. That's not what I'm saying. I think the ability to force project with the right unmanned assets is far better and certainly far more efficient, and it's far safer, and it has merits. And so I think people understandably get bogged down in the bad things, not realizing the fact that A, we don't have a choice because we're going to lose a war if we don't deeply invest in this. And then B, if done correctly, you're actually increasing capability by a lot and increasing safety by a lot. So sorry for the rant,
No,
but I
totally
feel very
makes sense.
strongly on that one.
Yeah. You mentioned you've been spending some time in Ukraine. Obviously, the war there has changed quite a lot, and there's plenty of unmanned systems being deployed already.
Yeah.
Are there any lessons you've learned from either side fighting the war?
Yeah, and this is where I have to strong asterisk on all of this stuff. I'm not an expert. It would be far better to talk to a member of Foreign Legion or just Ukraine. The Ukrainians know way more than I do. And so I don't want to be sitting here in the U.S. telling you what's happening in Ukraine as someone who's spent a combined 2 weeks in Ukraine. I feel semi-guilty doing so. But I do think it's important that we talk about what's going on over there. So there have been different stages of the war. So immediately on in the war, you had kind of tank and javelin battles, right, where Russians are pushing forward, Ukrainians are using 21st century Western tools to essentially push that back. And so you're using javelins to take out tanks. You see lots of direct combat with rifles. That then kind of stabilized, and then you saw what was called the artillery war. And this is just war of mass attrition, sending artillery in both directions. And this is one where we really started seeing the effects of long-range ISR drones on both ends. You started seeing the first proliferation, I can't say that fucking word today, it's tens of thousands of drones on both ends. And the really key unlock here was combining legacy munitions with modern ISR. So there's this push forever to get rid of artillery. And I was a teenager, I can't, no one knows this, I can't ever back this up. But the reason I was working on hydrogen at the time is because I was a huge advocate of a world where I can project fires 200, 300 miles forward, right? And I was looking at ISR assets that are available and realizing that if I can see 200 miles, but I can only shoot 15 miles, 25 miles with a 155, that's broken. And so that's why I invested in that. And there was a period of the war where artillery was super, super meaningful, right? So this is right when you start getting GPS jamming, but folks were still communicating relatively well. you see 155s being sent in both directions. Quads, similar kind of an effect to 155 at this stage, being sent forward. That went on for a year plus. I think we're entering a new stage of the war right now. So the Ukrainians published something a couple days ago, talking about the fact that across much of the front, they're outnumbered like 5 to 10 to 1. And so they're fighting almost exclusively on unmanned war in certain areas of the front, which is a really interesting tactic. So there are now enough people producing ultra cheap commoditized quads that they're treating them like bullets. Like even if in many cases they don't necessarily have a target identified, they're sending them all day. Like one person will send 50 of them, just like you would artillery shells. They've gotten better. This one actually went against the way I expected it to go. I expected us to continue having worse and worse RF jamming to the point where it was pretty much impossible. They've gotten better at communicating. So there are things they're using. They're using a lot of fiber optic, which is really interesting. And then lots of like directional comms. And then they've just gotten better at radios, like better RF happening there than I think anything happening in the US right now. There are other ways that we as the US can like invest in technologies to also avoid having to get into that world. But because of that, like I've been surprised that they're able to now start doing much longer range strikes, started using a lot more drones. They've also reached a point where they can afford to expend one quad on one soldier, which is terrifying. Like this is the first time in the war, because historically they were actually really hard to come by. But the result of that is that it's becoming almost exclusively an unmanned war. And that is not to say that the operator doesn't matter. That's not to say that the human doesn't matter. The human's arguably more important. The human's just being used to control more capable implements of technology. Yeah.
Cool. And how do you think the Russians are defending against that with humans?
Right now, they're sending a lot of humans forward, and it's incredibly sad. I mean, throughout the war, Ukraine has come up with something first. The Russians have done it themselves, and then used superior military industrial base size, supported by, in many cases, like Iranian or Chinese tech to go and fulfill that. And so the Russians right now are sending people forward, and they're getting picked off. So they've stopped sending vehicles, and they're essentially 2 or 3 operators are walking forward to do their missions. That will likely change, and you'll likely see the Ukrainian tactic being used on the Russian side, and then it's quad versus quad, it's long-range drone versus long-range drone. We've been seeing elements of this now for well over a year. But it's all a huge learning lesson for the U.S., right? So like the reason I take centralized manufacture as seriously as I do is like we had a Ukrainian company by the other day, and someone posted about their factory online, and literally within like a couple days they got a Russian Shahed dropped right into the middle of their factory. And so depending on where the risk curve you are as a company, you should be investing in different types of manufacture. Like Ukraine's all the way on the far right, and their manufacturing is something like it's done in areas that they can spin up quickly, that they can spin down quickly, that if they lose a factory, it's not a hit to their total sort of military industrial base output. But there will come a day where like if you're building a military industrial base for the US, you're expecting that thing to operate during wartime. And so it better be survivable during wartime. And so, yeah.
Switching gears a bit, I'm curious, who are some people, books, or resources that have influenced you the most and you think everybody should know about?
I don't have any good advice here. I think way smarter people than me have good advice. I
think whatever like you've learned from the most. It doesn't.
I mean, I've learned from people in my life the most. Like from my family, like crazy. Like growing up with like getting to help my grandpa. He taught me how to build things, how to think about things. A lot of my family members were in the DoD, kind of taught me how to think about this space. Now I'm really fortunate to get to work every day with people I look up to and learn from. I know I'm not giving you a great answer, but I'm not going to provide any unique insight there. Like go and listen to people who have done more things than me talk about how to learn about doing things.
Yeah. Do you think you had like more freedom than most people to experiment with stuff? That just... Yeah.
I think so. And it wasn't necessarily all given freedom either. Like I wasn't...
Did you fight for it?
No, I didn't have to fight for it. I just didn't. Like, I just kind of went and did things a lot. Yeah. But yeah, like I was super fortunate in the area I grew up to have the ability to work on these things. I'm super grateful.
Yeah.
Yeah.
Final question. Where do you see Mach Industries in the next 10 years? What are some big milestones you're prioritizing?
Awesome question. So within the next like 2-3 years, ideally by about 2027, I'd like to have an ecosystem of products that I think will be the most important in that future conflict, but that also add capability in current conflicts, right? So Viper Glide will target rolling out 3 to 4 products a year and have this ecosystem of products that works incredibly well together to win a post-unmanned war. And then we need to support that through decentralized flexible manufacturing. And so ideally we can go and be a large part in building the backbone of a survivable defense industrial base for the US and for our allies. That'll be Mach platforms, that'll be other countries' platforms, other companies' platforms. And I think that's in the next few years. Until I'm very, very confident about that side of the business, that's like my sole focus. Like that's all I think about all day, that's all I work on. That said, defense is really interesting because it tends to be the area, especially on hardware, where new tech is developed. And it's like pretty obvious, but like if you look at rocket engines, if you look at jet engines, if you look at commercial aviation, if you look at nuclear, if you look at like the computer, if you look at the internet, like it all tends to start in defense. And it's really interesting because it is a market, it's probably the most competitive market on Earth because the risk is existential, and because of that, it can support things that haven't quite reached the point of being applicable on commercial markets. And so I'm very excited about Mach to be able to absolutely push the edge as much as possible on some of these things. Right now, we're closest on the RF side. I'd like to do the same on propulsion. I'd like to do the same on materials and be the absolute best kind of hardware defense org on Earth with access to tech that no one else can access. And then I think on a 20-year timeline, maybe not a 10-year timeline, but I think a lot of that will be very, very applicable in commercial markets. And then for me, like, I'm a big fan of America's strength. Obviously, that probably goes without saying, but I think immediately the most existential risk is defense, and that is all I'm going to think about, and that's all I'm going to do. But long term, I would like to see a prosperous America across many fronts, and I think many of the technologies that have historically led to that are best developed in defense. Immediately, ecosystem of war-winning products, survivable, flexible, manufactured around the world to support our products and other companies' products, and then using that to build a machine that we have the fastest iteration rate, we have access to the most interesting customer problems, we can absolutely push the frontier of what tech humanity has access to, and there may be some interesting things that happen after that.
Awesome. Super
Cool.
exciting stuff.
Yeah, thank you.
Really appreciate your time.
Ton of fun.